Good afternoon, and welcome to the MARESUNEX seminar. Welcome everybody here in the classroom. Welcome everybody joining us via Zoom. It's my great pleasure to introduce today Mckinsey Lyon, and I will introduce her more in detail in a minute. But first, I would like to, as always, give a little run of show of what was going on in this seminar this afternoon. I will introduce our speaker. Then we will have a 40 minutes talk by Mckinsey Lyon, after which everybody has the chance to go into a breakout room online if they like. Here in the classroom, we will have small groups discussing a few discussion prompts, and after that, we will have an open Q&A. So with that, Mckinsey Lyon is a sixth-generation Idahoan. Her three-times great-grandmother, Eliza Hartley, came across the plains and over the Oregon Trail in 1864. That is just 2 years after gold was discovered in Idaho City and 3 years after gold was discovered in Silver City. So that was just at the beginning of mining in Idaho, our topic also in this class here today. Mckinsey Lyon is a Senior Vice President of External Affairs of Perpetua Resources. She is responsible for the government relations, so social license development, stakeholder engagement, and communications required to bring the Stibnite Gold Project through the complex regulatory approval process and into development. Ms. Lyon has worked for the project since 2011, first as a consultant and since 2017 with the company. Before joining Perpetua, Ms. Lyon was a partner at Gallatin Public Affairs, where she consulted on some of the top energy development projects, mining projects, and political issues in the West. Please help me welcome Ms. Lyon.
Well, thank you all. First of all, for the opportunity to come and talk to you a little bit about some of these issues and what we're doing. I guess I would like to start by saying I hope that all of you think about a career in mining, because I can absolutely tell you that when I was sitting in your chair, mining was not on my bingo card. I had no idea that this would be a career, one, that I would find myself in, or two, one that I would find so much passion and interest in pursuing. So I will just, no matter what you are interested in or you are studying today, know that the mining industry absolutely has a home for you. I was a history major, and my senior year of history, I got really interested in studying how colonial, kind of global colonialism had impacted labor and social justice issues. And I spent a lot of time studying those things around the world. And I look back now and think, oh, well, isn't that interesting how this interest in the movement of goods and a globalized economy very much influences my job today. So again, I will just put the exclamation mark on. Mining is touching everything when it comes to how our world is working, and you all belong there. But again, I definitely didn't see myself ending up here. So how did I get here? Well, after graduating school, and a history degree, which I love. It taught me how to think and how to write and how to kind of understand bigger context. It didn't give me an extremely clear career path. But I did end up working on campaigns, and I came back to Idaho and was working on political campaigns, where I then found myself working for a public affairs firm for a couple of years. One day, a mining company knocked on the door, and the mining company wanted our help. They said, you know, we want to start a new project here in Idaho, and we want to make sure that we're doing it right from the start. So we'd like your help. And I remember going to my boss and saying, nope, not for us, not for me, not interested. Because growing up here, all I had really seen about mining were the tailings that you see when you go through Idaho City. All I saw were the scars that were left behind. And I wasn't interested in more of that in my home. my boss at the time said, well, Mckinsey, it's probably exactly why they need you. They need your skepticism. And that company is this very same project that I am now working on. And the arc that I took from skeptic to now advocate was really influenced by three things. The first was the people, recognizing that the people who were coming on to this project, whether it was an engineer or a CEO, understood and had similar values to me, that this was our backyard and we were going to protect it. And they were also bringing values that, I mean, this is way too old for you all, so I'm totally going to like age myself. But when I was in like middle school, there was this cartoon called Captain Planet. And I feel like I grew up in this age of assumed environmentalism. And that's just what we do. And that this industry was no longer the gray-haired guy with a pickaxe, you know, making a mess in the river, that the industry had really changed and shared my values. The second thing that happened for me is I saw the regulatory process that, and I will talk more about that here in a few minutes, but that we as an industry couldn't do anything without the review and then the continued oversight of government and a transparent process for the public. And that gave me a lot of comfort, knowing that this wasn't the wild, wild west anymore of people just going out and digging or leaving a mess behind. And then the final thing that really kind of got me through this arc was going back and actually looking at the bigger global question. That when we don't produce here in our backyard, we are pushing the impacts of our modern life onto people that we will never meet, onto places we will most likely never see. And we are letting go of all control over how the things we use are produced. That means control when we need access or availability. It means control from an environmental perspective, and it means control from a human perspective. And I decided that if I was going to be a consumer, I really had to be okay with it happening in my backyard. So that's kind of my big picture. And I think that critical minerals in particular right now are a really interesting topic, because everything you think about, whether it's how we're producing energy, is it clean and do we have enough? Whether we're talking about the need for new technology or manufacturing, or we're simply talking about geopolitics, critical minerals is finding itself at the core of all of these big questions that we are now finding ourselves struggling with as a country and really as a globe. So to start with the question of, well, why America? Why American minerals? I think you can look at this as a really quick snapshot into a current crisis. So all of the blue on our periodic table represents China's control of that mineral. So how much do you think we're going to need gallium or germanium or antimony or manganese, or I think helium in the last couple of weeks has gone just berserk because of the conflict in the Middle East. And so this is a really interesting map to show ourselves where our vulnerabilities are when we want to access the things we need. The United States has a list of 50 critical minerals, and we've designed that list based on a couple of criteria, but really simple criteria. A, do we need it? So is it important for our economic security? Is it important for energy? And is it important for national defense? That's the first bar of the critical mineral test. The second bar of the critical mineral test is, do we have access to it? How vulnerable is that access? And so the list has grown from about 30 a few years ago to now 50 critical minerals. And so when you look at every year, USGS publishes a new report on these critical minerals that will report out, where are we getting it? What are we using it for? And what is our import reliance? And it is shocking to look at that list. It varies each year, but typically somewhere between 25 to 30 of those critical minerals, we are nearly 100% reliant on other countries for. And so whether it is a question of a shipping disaster, or a question of a global pandemic, or a question of geopolitics and another country who's not necessarily an ally turning off that tap, what kind of a position does that put us in when we want basic things? Or, we want very specialized things. So I think this is a really important kind of storytelling aspect of being able to visualize what kind of situation we're in at the moment. Our project is a gold project. 90% of the economic value of our project is gold, and I'll talk about that in a little bit. But we also have the only identified reserve of the critical mineral antimony. And up until very, very recently, we weren't producing any mined antimony in this country. Right now, we are producing some, but it's not on a commercial basis, and it's not being sold by the market. So we are in a bit of a pickle, particularly because 90% of the world's supply of antimony is controlled by China, Russia, and Tajikistan. And that vulnerability became very real in 2024 and 2025, when China put an export ban on antimony. So not only are they producing about 53% of the world's antimony, not just in China, but from antimony resources that they've purchased around the globe: Africa, Canada, South America. So they have been very strategic in finding these minerals and getting a controlling access of them. But they've also got a real handle on the processing side. So overall, 80% of the world's antimony is processed through China. So when China said, you know what? Too bad for you, you're not getting any more, it was a real crisis. The price of antimony went from about $3 a pound to well over $35 a pound. You had businesses in America, particularly, interestingly, car manufacturers, start receiving force majeure notices, which are notices from their supply chain saying, we're out. We can't produce more of this lubricant you need, or this glass you need. Because antimony, someone said it earlier today, and I thought it was the perfect phrasing. Antimony is like a pixie dust, right? Really small little quantities in many different types of products. It clarifies glass. So the solar industry right now is incredibly reliant on antimony. It is a metal strengthener that actually helps with heat resistant properties, so that it helps metal not expand when it gets hot. So it's used often in chip making processes. It is used in batteries, both clean energy batteries and just regular acid batteries. And interestingly, antimony trisulfide, aka stibnite, is a form of antimony that is the irreplaceable primer in about 300 types of defense munitions. So when China cut us off from antimony in 2025, they had also 3 years earlier in 2022 cut off all defense sources of antimony trisulfide. That as a country, we were single sourcing from China. So putting control of these very basic building blocks of the things we need in the hands of folks who don't necessarily share our interest is a moment of crisis. It is a moment of real vulnerability. And it was that export ban combined with things like COVID and then the Biden administration interest in clean energy that has finally really brought all of this to the surface to say, we need some solutions here. So if we are going to do it here, what does it take to do it in America? Well, in 2024, there was an S&P Global report that said, from identifying the resource, so saying, I have antimony right here, to getting it out of the ground takes 29 years in America. Who wants to wait 29 years the next time a non-allied nation cuts us off from what we need? Probably not me. Anyone want to guess, just show of hands, if you have a guess on where we fall in the world, the ranking of how fast or how slow we are? Anybody? What was that? We are the second worst in the world, second only to Zambia. So we have some ground to recover here when trying to solve this problem. And this is a problem that is multi-layered. It is not just a government problem. It is not just a permitting problem. It is not just an environmental problem. It is a lot of things combined with a system that's not working very well. So that's where I think our project comes in. So to take a step back, the Stibnite Gold Project is our single asset. As a company, we have one project, and it is located in central Idaho, in Valley County, which to get there from here would take you a good 5 hours. So you would go here to Cascade. From Cascade, you would go up Warm Lake Road. Then you would either go down the South Fork Road or Johnson Creek Road to the little village of Yellow Pine. Has anybody been to Yellow Pine? Nice. Have you been to the Harmonica Festival? All right, you can't miss it. At least do it once. I did it once and I thought that was enough. Yellow Pine is a village of about 20 full-time residents. So very, very tiny place. And then you get to Stibnite. So that's where we are. We are a project, as I mentioned, that has both gold and antimony. We imagine, or we anticipate, that this project is about a little over $2 billion just to build. And I'll talk more about that later. We anticipate needing about 550 or more people when we're in operations. But we've also done two things that I think, in addition to having antimony, that differentiate the project. The first is that this is at an abandoned mine site. So we designed our plan to return and actually use a lot of the investment to address environmental harms that were left behind. And then the antimony piece is the other thing that I think really makes the project different and strategic because of the national defense need. So the story of Stibnite is actually a lot like the story of today. Mining here started in about 1899 as a part of that gold rush happening in Idaho. So there was gold and silver being produced. But then, on the eve of World War II, the Japanese invasion of China and blockade in the Pacific meant that all of a sudden, the United States didn't have access to antimony and tungsten that we were then sourcing from China. And we knew that if we were going to be drug into World War II, we would need both for national defense. So the government set out, and they actually found both at Stibnite, Idaho. They commissioned the mining company there to produce both for the war effort. And overnight, it grew to about a town of 1,000 people. If you worked there, it counted for your war service. And after the war, the men and women of Stibnite, Idaho were credited with shortening World War II by a year and saving 1 million American lives. That's how important it is to have access to the things that you need when you need them. So in returning to Stibnite, let me start here first. So on the other side of that coin, this like, oh my gosh, we did this amazing thing here in the middle of nowhere, Idaho, that had this influence on the world. We also did it at a time before there were real environmental regulations in place and before there were requirements on how to mine and how to leave a place when you were done. So when war demand dropped, most of the mining went away. And over the next couple of decades, there was some small gold production that returned, but largely not a lot of work. Between 2000 and 2012, There were then 3 CERCLA decrees, which are like Superfund agreements with the government and private companies. And at this point, the government and the old private companies said, you know what? We're going to invest a little bit. We're going to try to like patch it here and there, but we're all absolved. Everybody can walk away. So everybody walked away, leaving behind the East Fork of the South Fork of the Salmon River, now flowing into this abandoned mining pit. We have millions of tons of legacy tailings, which is mine waste, sitting in this river valley, unconstrained. Nothing around it to protect all of this waste from interacting with ground or surface water. So right now, we measure about a ton of arsenic is leaving in this water system every single year. So we got a water problem. And then just sedimentation, right? Just really impacted habitat that there wasn't anybody responsible for because we'd all been able to walk away. But what they also left behind when they left Stibnite was about 4.8 million ounces of gold and about 148 million pounds of antimony still, and some silver. So we sat here, or my predecessors, and we said, well, starting a mine is not going to be easy. And this is a mine that's complicated because there's a lot of previous impact. How do you even treat that impact? Like, what do you do with all this mess left behind? And actually, I love this story because it was actually the wife of our geologist who was so tired of having him come home after visiting Stibnite and just whining about, oh, there's all this material left there, but it's just so complicated. And she finally looked at him and she said, so be the ones to clean it up. And that actually was the colonel that started this company. He then took that as the mission and the vision and started to get investors and do the work that it would take to figure out how to mine this place again. Because from a philosophical standpoint, we were willing to be a part of that solution. I will also say economically, this balance between gold and antimony is really important. Most critical minerals are critical because the market economy doesn't provide the right conditions for their production, or they're controlled by somebody else. If this was just an antimony mine, it would never be economically feasible. You couldn't spend $2 billion to go get antimony. It just wouldn't pencil out. So the fact that in this place it is paired with gold is actually incredibly significant, because gold becomes this economic insulation, right? A really good example of the need of that is there's a cobalt project in Idaho, one of the only potential cobalt mines in America. A couple of years ago, after almost 20 years of permitting and getting ready, they were just weeks, days away from being able to open their mine and finally produce cobalt. And then China flooded the market, and the price of cobalt dropped so low that they had to stop all development. And so having something like gold is actually incredibly valuable because it will drive the economics regardless of what's happening to antimony on the greater scale. So here we are. We're a mining company, and we said, you know what? We want to return to an abandoned place that had been mined for over a century. We will go in and front load much of the environmental work as we can from all the legacies that were remaining. And at the end of the day, we want to walk away from this mine having left it better than we found it. And in doing so, provide value. We have to provide value to shareholders, want to provide value to our communities, and now also provide value to our country because of that antimony. So to do this, just very quickly, we have a project. Today, if you were to go up to Stibnite, which by the way, you're all welcome. If you ever want to come, please let me know. I love showing it off. It's fascinating and it's a beautiful, beautiful day to get up there. Right now, there are 2 open pits at Stibnite. We will remine both of those, making them bigger, deeper, and wider, right? We will also take this third area called Hanger Flats, where there's a bunch of old underground workings that they tried to connect back in the war era. and we'll make that an open pit. But we will also completely backfill. So when we're done, we will put enough material in both Hanger Flats pit and that Yellow Pine pit to make sure that they are back at ground level. And in doing so, it actually allows us, that river that's dropping into that pit today, it actually allows us to restore its natural flow, reconnecting many miles of habitat. So mining has an impact. I don't want anyone to think that I'm trying to tell you that mining isn't like digging holes. It is absolutely digging holes. And our job is to figure out how we minimize that impact and how we do it responsibly. And so it also comes with about a little over 50% of the project footprint is on legacy footprint, so old disturbance. But the biggest part of our new footprint is our tailings storage facility. And that's the question of, well, you grind up all the ore, all the rock, and then the tailings are what's left behind. And you have to store that somewhere. It has to go somewhere. And so that is where we've got it contained so that it's not interacting with ground and surface water like it is today. So we designed a plan, right? We designed this plan that was going to identify how to make things better, how to mine safely, how to get what we need while limiting our footprint. Now, the question became, well, how do we get approval? It takes over about 50 permits to get a mine. Those are federal permits and state permits and county permits. The biggest part of that is NEPA, the National Environmental Policy Act. We started that process in 2016, and we finished it in 2025. It was one of the last acts of the Biden administration to give us a positive record decision on this mine so that we could move it forward. And this has been no small feat. I will say that to get to this point today where we have all permits in hand, took about 6 years of engineering and doing all of the economic resource work to identify where is the gold and antimony and how are we going to get it out of here. And 6 years of listening to our community as we were trying to design this plan, a plan to operate a giant mine in the middle of nowhere, which means roads and power, and how are you working with your community? And then we built our plan and we submitted it to the Forest Service. That process, that got 8 years on here. It's actually now so much longer than that, about a little over 9 years to go through that large environmental process. To go from identifying our resource to getting permitted, it was a $400 million investment without making $1. There's also this giant capital requirement to do what it takes to get to that point. And now we're looking at, if we're at a phase of, okay, we've got to build a $2+ billion project, we've got to raise money. And we're in that process now, and we're building a team now. And then it'll take us about 3 years to build this project before we can move into construction. But part of the how you do this, how you get regulatory approval, one of the ironies, I think, of our permitting process in America is that theoretically, it should be very iterative, right? You submit a first design, and we had 10 state and federal agencies around the table, and 2 public comment periods of getting feedback from people. But every time you have to change the plan that you gave, even though the process is asking for changes, asking for input, every time you have to change the plan, it also sets you back a year or 2 years or 3 years. And so it becomes a very long process. And it can be very harrowing also. But a couple things were really important. Like, we had 2 public comment periods. Over 23,000 people provided comments on this mine. And through that process, we learned some things. We learned that we really needed to try to make our project footprint smaller. We learned that the risk of long-term or permanent water treatment was not okay, and that we were going to have to figure out some better ways to manage water. And we learned about that water temperature was potentially a risk to the project. And so we were able to go back to the drawing board and say, okay, how are we going to fix these aspects of the plan and truly make the plan better? And at the end of the day, I think we've got a project that does what it intended to do. We are going to see about a 47% reduction in arsenic in the East Fork South Fork of the Salmon River. That is great. That is a measurable improvement in water quality. We've eliminated the need for permanent water treatment. We've seen about a 5 degrees Celsius reduction in water temperature from the original plan. So trying to keep water temperature as cool as we can. In some places, actually decreasing water temperature over existing conditions. And that's how you use things like shade and low flow corridors that can really help water management, especially in the early years. And at the end of the day, we get to open over 20 miles of fish habitat. So today, salmon, Chinook, and steelhead all flow from the Pacific. They swim their hearts out to get to this pit. And they get to this pit, and that's where they stop because they can't get beyond it, to these spawning grounds upstream. And this is not a successful spawning ground in this pit. Let's just start there. And so by being able to open up this fish habitat, and we can talk more about how we do that, but it provides this a very, very tangible benefit. Because this is what, when we get to backfill that pit, after we're done mining it, we backfill it. And we worked with local river restoration guys who said, at first, we had the river going from point A, a little meander, to point B, a little curve. It looked great. And these river restoration guys from Idaho came to us and they said, well, awesome. What if we could design your river restoration so it meandered? And if it meandered, you'd get more stream feet. So you can actually increase the amount of habitat you're creating. And that meander would support more riparian habitat and wetlands. And we're like, oh yeah, that sounds great. Let's change it. And then they came back to us again a little while later and they said, well, you've got these other streams. What if we braided in these other streams and that would create juvenile habitat? We're like, yeah, let's do that too. And then they said, and actually, what if we formed your backfill of the pit into a more of a true floodplain, so that we create this space where the river can actually flow dynamically. It can move and change over time by how we shape the space we're putting it in. And by doing that, make a system that is dynamic. And it's this kind of stuff that I think mining of the future is going to have to get really, really smart about and think creatively about. Because this wasn't natural for a bunch of mine engineers to think about. It really took bringing in these environmental specialists to help us kind of figure out how to push it further. I mentioned that this was an expensive process. It was very expensive, as I said, about $400 million. When China did that first cutoff of military grade antimony in 2022, I was giving a presentation and immediately afterward, I got a call from some people from the US Army and they said, so you have antimony? And we said, yeah, we have antimony, but we're looking at another permitting delay. And we're really nervous about our ability to continue to get money from the market because the market is kind of exhausted. At that point, we were like $250, $300 million in, and we still didn't have any permits. And so we then had to apply to a very old tool called the Defense Production Act, which actually was started in the 1950s after World War II's response to build the industrial base. And so we applied to receive funding that would help us continue through the environmental process of permitting. And so we've received about $80 million through that. We are now also in the process of using another tool in kind of the American mineral tool belt through the Export-Import Bank of the United States, which is typically a tool that American companies can use to go overseas and start businesses and be competitive against countries that might provide more economic incentives somewhere else. A few years back, Congress passed a program for the EXIM Bank called Make More in America. And I said, well, maybe we shouldn't just be giving all of this money to go overseas. How could we provide some of this debt financing to help companies actually produce jobs here in America? So we are well under our way to developing a finance package with the Export-Import Bank of the United States for over $2 billion so that we can actually have the money at hand to go build this project. So that's a lot of like, what does it take functionally? There's also a really important social aspect to impact. And the first kind of concept of like, you can check every box in permitting. And you still might not get a permit if you don't have your communities and your political leaders on your side. If they don't trust you, you're not going to be able to go build a mine. So when we talk about how we build community trust, there are a couple of ways that we need to be thinking about. We need to be thinking about, well, what are we giving back? What's in it for somebody else? And in our case, part of that equation is jobs in a very rural community. Another part is infrastructure. A lot of our rural communities in Idaho are largely federal land, which can make it really hard to develop and have a tax base for infrastructure. So this project is going to develop, we're going to upgrade about 72 miles of transmission line. We've got to build over 30 miles of road. And then we've also put in place a profit sharing foundation. It says about 1% of our profit as a company is going to go into this foundation to help avoid some of the boom and bust that you can see in natural resource industries and help support and, pay back. Like if we're going to be utilizing these minerals, we have to make sure that the value is shared. And then it also comes down to the fact that your actions speak louder than your words. And so we have really invested heavily in time and people to make sure that this just wasn't a PR campaign, right? So we've put $20 million in already to restoration activities at Stibnite to improve water quality and river habitat today. We try to be really transparent. We can do that through sustainability reporting, transparent data. Did we have any spills? Did we have any accidents? What does our company gender makeup look like? That kind of reporting can really help build trust because we're showing who we are and what our performance is doing. We have things like a dark skies policy where our mine site and all of our offices in Valley County are trying to be dark skies sensitive. How can we use the right shade of lighting, the right temperature, pointing in the right ways to reduce our visual impact? Like these are easy things that we can do, but definitely take a lot of thought and planning. I also have a whole top 10 list of like how not to F it up with communities because you see it a lot, right? Like people running into communities saying, oh, we know better. We know what you want. We know what you need. We know what you're worried about. Just listen to us. Everything is going to be fine. I think we've seen that particularly in a lot of natural resource or energy projects that you can lose the support of your community very, very quickly. And I think there are some best practices on how to do that. And I'm happy to talk through some of those in our discussion. And then, of course, the question of, well, once you get these minerals out of the ground, how do you keep them secure, right? So just a quick snapshot of kind of downstream considerations. So antimony from stibnite can go in a couple of places. You can produce antimony trisulfide, and that's like the military grade stuff that's needed for primers. Antimony metal, that's more of a smelting process. Antimony trisulfide is a liquation process. Antimony metal is smelting, so a lot of heat. That will be things for like metal products, bearings, batteries, semiconductors, alloyed products. Oxides are a real growing kind of commercial use. So that can, depending on the type of antimony you have, kind of determines what kind of processing it will need. And there's also other forms as well. But right now we're very limited in America on what kind of processing we have available to us. There are processing facilities here today. We're also looking at potential hydrometallurgical options that can help us retain some flexibility when looking at what kind of products we need at the end of the day. But it is a really important consideration of like, let's not just mine it here and then ship it all back to China to be processed. And it's one of those big questions that we still have to answer more globally as a country when we think about supply chain. And then finally, we have just started a really cool project with the Idaho National Lab and the US Army, whereby we are building small modular processing facilities. So this will be a demonstration plant. It's basically the size of 2 Connex containers that will help us figure out exactly how to process our material into what the military needs. But it's a really interesting concept. When we think about surge capacity, all of a sudden you need a lot more than you have on processing capacity you have on hand. Can you build small modular components that could be transported to a mine site, that could be transported to a manufacturing site, to help kind of address that processing question? A facility like the one that we're building right now will be used to test antimony production, but it could be used to test tungsten production. It could be used for gallium and germanium. And it's a really, I think, fun way to think about this now very Idaho supply chain, and where the material science happening at INL can be really, really useful on the mineral and commercial manufacturing side. So very quickly, this is a big project and it's really complicated, and it touches on a lot of like really, really complicated things. But at the end of the day, we also just have this remarkable opportunity where we can go back to an abandoned place. We can help improve some of the conditions there, and we can produce what our country needs at a time when it is very much needed. And a few months ago, we had Major General Rime from the US Army come visit Stibnite. And, he talked about the arsenal of democracy. And it's not just in things that we need for weapon systems, right? But all of our technology, all of our energy demands, all of the minerals we have are very much a part of what has created and sustains our daily lives. And starting to think about it from the ground all the way to the round, I think is really incumbent upon all of us, whether we care about national security or energy future, or just simply having the things we want in our car to drive and our cell phone to work. But they are definitely questions that will define, I think, our next couple of decades. So with that, I think I'm very happy to kind of start us into discussion.
Cool. So those attending from online have the opportunity to join a breakout room. Here in our room, we were discussing these questions in our teams. We have them up here, and we'll meet in 5 minutes back in the classroom. All right. So now it's the time that we are back here. Who would like to open the floor? 1, 2. Well, I have the mic here, so let's start.
So realistically, do you think we'll ever be able to catch up? I know it's been like a big deal, especially since China has pretty much been soft invading the Middle East and Africa, and using ports and building mines, including mines in China. We know permitting here in the United States is terrible and it takes a lot of time. But do you think it's almost like safer to kiss China's rear end to keep things calm so we can continue to get those minerals instead of trying to like fix it and piss them off?
That is I mean, you're bringing in, I think, so many really good kind of components of what is happening. And I just come back to the fact that I really believe that as a country, we can do anything, right? And I think, seeing Artemis circle the moon, or even right now, just remembering what we could do in the 1950s and the 1960s, what we could do during World War II, when we all put our minds to it, we can get a lot done. And I really think that that is part of the momentum that is building right now, is this recognition of like, we don't have that choice. Because even if we wanted to go placate somebody who owns all of the minerals, that doesn't mean that they want to play along. And so I just don't think we have a choice, but it will be decades, and unless there is a generational level of both investment and consolidating government oversight of the process. Because right now, when it's happening in all of these different wings of government and the left hand doesn't know what the right hand is doing and there's no mission driving it, it can be very hard.
I know we've been talking about this for a long time. Sorry.
You're good, but you're not that good.
Yeah.
I know they've been talking about this for like a long time, and it's been a topic for years. Are we thinking we're gonna potentially meet that 2050 goal? Is that something that is even achievable, like realistically, is what I'm kind of searching for.
The 2050 goal on kind of clean energy.
Mhm.
So I haven't seen any recent reports out of this administration. I think we could still look to EU and the Paris climate efforts to kind of see where we are and check in. But I don't think we're going to make 2050. But does that mean we don't try? And maybe we're 3/4 of the way there, maybe we're halfway there. I think that is worth the effort to still keep trying. Because it's not just how much more can we dig out of the ground. And I don't want to overemphasize that we just need the minerals, because we do. I mean, we need, I can't remember the numbers anymore, but it's like 30 times the amount of copper, right, that is currently produced in order to meet those clean energy goals. But it also means at the same time, we have to be thinking about how we reduce consumption. How do we reduce energy loads? We're not doing a very good job with that right now. And how do we think about new technology in a way that can recycle more? But we just can't recycle ourselves out of this problem either.
All right, so the $20 billion plus that the Import-Export Bank is providing, is that like in the form of a loan in which you have to pay that back eventually? And also, are there specific permissions or limitations as to what they are allowing you to use that money for?
Great question. So it's about 2 billion, so not 20, but it is 2, which is
Sorry.
still a lot of money. I will absolutely agree to that. And there are a lot of requirements around this. Like, we started the process 2 years ago, and we're not there yet on clearing specific hurdles. And those hurdles are both from a financial, like banking perspective, like, is this a good investment? Does the government think that they will get their money back? Because it is just a loan in simple terms. So we have to pay it back, and we pay it back with interest. And yet the requirements on it of the Make More in America program puts requirements on it, like how many jobs, local jobs we have to create. Then there are other requirements there's another program called the China Transformational Exports Program, or CTEP. And that's, requiring that some of this is solving that China competitive issue on antimony. So does our antimony need to stay in domestic control? And then there are other really interesting social and environmental requirements. Like, we have to follow the Equator Principles, which are a series of kind of international standards on human rights, on climate, and on labor conditions. And so there is a lot of oversight going into this process, which is warranted. If we're going to be using some of the backing of the US government to fund this thing, then let's make sure it's done right and that government is paid back.
Hello, thanks for the great talk. I have kind of 2 questions. So the first one is you provided a lot of predictions that the cleanup that you're doing for the existing mine site, and then the cleanup that you'll do at the end of the mine site will improve the overall water quality in the East Fork, South Fork, and the South Fork. I'm slightly skeptical that having an active mine at the headwaters of the East Fork, South Fork will actually improve the water quality. So I'm curious, like, what the time frame for those like estimates are. Is that like, from now it will improve the water quality, or is that like we will have to take a water quality hit for like 30 years and then we come back? And then my second question was about so I think it was $150 million pounds of antimony you said was in there. And then you had a small statement below that saying that the U.S. contributes or the U.S. requires about 50 million pounds a year of antimony. That's what we use. And so I'm curious, like say the U.S. uses Perpetua as like 25% of their antimony sourcing. That means that you guys are a reliable that carries this Stibnite mine carries the U.S. forward 10 years in antimony supply. Or if it was 100%, say 2 years. What is Perpetua looking at additional options to expand the site or to expand into new sites in order to further that timeline?
All really good questions. So I'll start there and I'll move my way back to the first one. So I am just point, like, to be very factual about it, one project can't be the only solution. Like, we absolutely have to have an antimony pipeline coming on board. When we look at kind of what our project as defined right now could provide, you're absolutely right. It's not all of it, but we can do a pretty big chunk. But what we look at what the Department of Defense needs, we could actually satisfy their needs probably for decades, right? And so it really kind of comes down to, well, which of the needs are you prioritizing and how are you getting there? And so, we are probably always doing work to redefine our antimony resource within the existing permitted mine, to see where we can go find more. Because I will be very honest, when we did most of the mineral resource work on the project, we were really focused on gold. And so most of our antimony numbers are coming from where we were looking for gold and shoring up those numbers there. So I can't make forward-looking statements, or if I do, I will also show you the 3 slides at the bottom of this deck that basically say I can't make economic promises around the resource itself. But we are very, very aware of the ongoing driving need for antimony. And we just happen to be the first in line to production and the first one to kind of help satisfy some of those emerging needs. Which is also why things like that mobile processing center at INL can be so useful in that process. And then on the water quality side, you are right. We have to look at this globally. I wish I had in my deck, and I don't think I have in this one. And we've got it very well spelled out on where you start to see water quality improvements. The first place you start to see water quality improvements at Stibnite today is when you pick up the 10 million tons of waste that are sitting unconstrained in that valley in the river today, right? You pick that up, you're going to improve water quality. But yes, by then disturbing other parts of the site, do we have an impact on water quality? Absolutely. Part of the requirements of a company like ours, though, on what water goes back into the system, right? So if we are using or touching water, we have to process that water. But when we have to process it back to state standards. So any water that touches our site from us or is in our processing facility before it goes back in that river system, it has to be at standard. And so do we make it perfect right away? No. Do we see measurable improvements and some that are, much better at the end of the mine than at the beginning? Absolutely.
So you guys are trying to help preserve national security, right? And what are you guys getting in exchange for that one from the government or from the people?
Great question. So part of what we're getting in exchange for the antimony, first of all, was the 80 million. So we've had about $60 million from the Defense Production Act, and then $20 million in partnership with the Army.
Is that interest-free?
Yes, it was a grant, so we don't pay that back.
Oh, okay.
That's just an industrial base. You need this to survive, so it is a grant. Versus the loan that we pay back from the Export-Import Bank. There are also different programs happening right now. Under the Biden administration and then continued through the Trump administration is a program called Fast 41. And basically it says, if there is a national interest need for project development, and it didn't start with mining, it started more with roads and power infrastructure, that you could get it's not a fast track, but you could get kind of coordinated permitting, right? that this Fast 41 program that sits in the White House would help oversee all of the different agencies that you needed. And just that alone can be extraordinarily helpful when you need to get through the system. And so now projects with critical minerals or other minerals, I think mainly critical minerals, are getting access to that kind of Fast 41 program.
All right. Thank you.
Yeah.
Alrighty, so I just want to ask, one, thank you for the great talk, and two, so what are the most important things that you think could be done to secure mineral independence on a policy level?
Such a great question. There are some interesting things happening right now on the policy side. So one, we need our geology services, USGS, needs to have the resources to help figure out where the minerals are in America. Let's start with that. Where are the minerals and where are places that have better conditions for mining versus not? And that kind of first evaluation of like, okay, here's what we have. Then we look at kind of some of the technical hurdles. And I think that there could be additional opportunities on the policy side to support some of the early exploration work. Right now, for when we wanted to do our exploration work, which means putting drills in the ground, that create an impact, like it's like this big, right? Like the drills. It took us 2 years to get a permit to go do that. And like if we could kind of speed up that time frame a little bit, we could know faster. Like, is this economic? Like, is this a good idea or not a good idea? Is what we're looking for here. And then, of course, on the permitting reform side, no one in industry that I know is going to say, please lower environmental standards. Nobody I know. And I would never argue for that. What we do need is a coordinated system. So one thing on our site, for example, we have both steelhead and Chinook. Bull trout, Chinook and bull trout. And the bull trout, as adults, like to live in the yellow pine pit in that lake. And their favorite snack are smolts, steelhead and Chinook smolts. So they eat this species, but they live in this body of water. And we have one agency that is controlled, like the bull trout are their species, they have to protect. And I have another agency who has to protect the steelhead and the Chinook. And so they're competing interests. And so trying to find a solution where you're like, wait, you've all got competing interests here. How do we stop saying, well, sorry, that won't work for us? And instead get to a table where you get everyone from each of the agencies at a table to say, we have a timeline that we're going to try to meet. And we have a mandate to try to find solutions, not rubber stamp, not just say find. How do we actually engage with industry in a way that finds solutions? If we can move permitting towards that, we'd have a lot easier time on the other end of permitting, which is litigation. Every mine gets sued, and that has the risk of stopping that mine and that production. And so if you go through 8-9 years of permitting and multiple layers of government to get those permits, and you've done all of the environmental work to do so, there also should be some protections on the other side to make sure that claims that are brought forward are real and that they can be addressed in a manner that is also very timely, so that we're not just sitting and languishing, because that's part of that 28-year or 29-year time frame. But at the end of the day, coordinate your agencies. If we could better coordinate our agencies from a policy perspective, we'd be a lot better off.
Hi. So it seems like Perpetua spent a lot of money developing the Stibnite mine. So I think you said maybe somewhere in the hundreds of millions. So we were wondering, once the mine is at full operation, how many years or months will it take for Perpetua to break even or make profit off of the Stibnite mine?
Very good question as well. And if you want all of the details on that, we actually have a press release that went out last week with updated economics. Because if you've been following the price of gold, the price of gold has also been at some pretty record highs. But when we looked, I think we picked a price of gold that was in the 4,000 range of whatever day it was when we put out that press release. And if all costs stay how we're expecting them to stay right now, with all the asterisks behind that, we're looking at a 2.5 year, 2 to 3 year payback. Which again, when we're accessing government resources, is a nice thing to be able to say. We're not gonna, it's not gonna drag out forever before we've paid off the debt that we've taken on. So it can be very economic.
Thank you.
I was wondering if you could elaborate on what the asterisks are that you use to make your gold price estimates. Because what is it today? It was like 4,700, and 2022 it was 2,500. I don't know. It seems super inflated. So I'm just wondering what those asterisks are and how big of an effect it would be if it went leveled out.
Yes. And that's great. And typically when mining companies are doing our feasibility studies, these economic studies that we're looking at, that we publish, and then particularly as a public company, our feasibility studies typically take a low, medium, and a high price. So when we first set out, our like median price for our gold was $1,200. This project could be economic at $1,200 gold. And in fact, it would be economic still in the 800s, like 880s. And that was, at a time when things were also less expensive.
Is that only accounting for the gold? Do you even account for the antimony at all?
We do. It's about 5%. So it's smaller. But again, when you've got the price of antimony that's even more volatile, right? It's really nice to have the gold price that, while it's been going up quite a bit and it's projected to go even higher. We know we've got a lot of room of comfort in there. But I am not the project economist, but I do, if you are interested in it, it's on our new presentation on our investor side of our website, and a full report on how all of those numbers are calculated. And because the other side of that equation is also cost, right? When we started out, I think this was a $1 billion project, then it was a $1.8 billion project, and now it's a $2 billion project, or $2+ billion. So that side has been growing as well.
Thanks.
And then I will have to make sure you all see the forward-looking statements.
All right. Got a whole time for that.
Yes.
Where does Perpetua plan to have the processing of the gold and the antimony done?
So we don't have a commitment yet. We are on the antimony side specific, we're very focused right now. We did an RFP, a request for proposal, earlier last year that basically said, okay, if you in America think you have the capability to process our antimony, please submit, some answers to these questions so that we can start evaluating who has, technical capability, who has the capacity, and then also a look at experience. And we were weighing end product, right? If you have a hydrometallurgical facility, you have a lot of flexibility in in what you can make from our antimony. If we need, like for our military antimony, for example, that will most likely be directed by the US Army, but it needs a flotation process and then perhaps a liquefaction process. So what we're building right now with INL is helping us answer that question, and then kind of where we could place potential capacity for that processing. There's a processing facility in Montana, a company called US Antimony. They basically have a smelter. There's Korea Zinc, which I think it's over on the East Coast. Do Run is another company that processes antimony up in the Mid-Lake region, or the Lake region. What state are they in? Maybe one of them. I can't remember which state. So we're looking at all of those opportunities, and even trying to figure out the defense demand is clear. They've told us exactly what they need and how much they need. The commercial side is so much different because, like I said, it's like pixie dust levels of additives to products where there's not one buyer or not one industry that says, we can take it all, just make it like this. And so it is a bit of a conundrum on how we ensure it stays here and is useful in strategic and important ways to the commercial sector.
Nick, another very short question. We have time for one more question.
So you mentioned like making sure it stays here. I'm just curious how like committed Perpetua is to making sure that these things stay within the US. Like if this bid goes out and you guys can't find somebody who you trust, what are the odds that this ends up just going straight over to China and we're not really accomplishing our goals of supply chain independence from them?
I mean, I can't speak for the government, but I don't think they would let us. And there are rules on the books that can prohibit that. And the fact that we've got now all of this money tied into from the government also is a pretty clear directive on it's going to stay here. You know, I think one of the things that the government is looking at right now, whether it is through the proposed Project Vault that kind of becomes like a stockpile, is also looking at where can collaboratives be put together around processing. Because my antimony alone probably won't be enough for someone just to go build one new processing facility, right? And so it really becomes, how do you put the bigger map together? And things like hydromedical or hydrometallurgical facilities are interesting because it wouldn't just be antimony, right? They could take all the kinds of other different materials. And that's a little bit where, to answer the other question about what can the government be doing, that is a place where the market isn't necessarily coming up with immediate solutions, in part because of the cost vulnerability as well. It's really hard to say, I'm going to go build a processing facility and it's going to be totally economic, even though I can't control the price of anything on the other end and there's all this volatility. So I do think, just bigger picture philosophically, it's a really important place for government to give a little bit more directive and maybe pooled resources to help the industry keep materials here.
Well, these were a lot of great questions following a wonderful, wonderful talk. So let's give a round of applause and a thank you for Mckinsey Lyon.